Good afternoon, everybody. Welcome to a wonderful but cloudy Monday afternoon of Chem 170 with your host, me, Dr. White. If you notice, I'm in a good mood because I didn't tell you about this last week, but I couldn't get my snowblower started. I figured I'd start it before I needed it. And I should tell you, I've had that snowblower for, are you ready for this? 24 years. I couldn't get it started. A couple years ago, I had to replace the primer bulb, take the whole thing apart. Oh, that was a job, but it worked. So it was, what do I do? Because the new snowblower is about $900, a lot of money. I call up my best friend. We've been friends for over 50 years. He's a real good fix-it guy. He said, well, did you check the spark plug? No, I didn't. Well, I changed it out, primed it, pulled it once, and it started like a champ. And that saved me about $900 for about a $5 spark plug. So I'm happy. All right, let's go through this is our final week together. Next week will be final. I'll give the final and I'll explain more in a little while. All right, what I like to do today is, first of all, go through what's coming up next week. Then I'll go through test number 4, and then I'll do something I've been doing many years, teaching Chem 170 today and Wednesday. Since we don't have a lab on Wednesday, we're all done. Don't forget, hand in your labs. I will do a complete review for the whole semester. And this helps students. And you can come back and watch it on video too. All right, let's go through. Everybody should see. Let me move some things out of the way. Chem 170 final exam information. All right, a week from today, on the 12th at 1 p.m., maybe even earlier, at that time, I will be emailing you the password for the final exam. You'll have until Tuesday, 1 p.m. to take the final exam and upload your answers. I reserve the right to subtract up to 50 points anyone who doesn't follow instructions, meaning upload as a PDF file, and if you don't, upload it on time. Now, historically, and by now you probably figured out, I've taught this course once, twice, three times, a lot of times. I'm going to give you as much time as you need. Either you know it or you don't. It's one of those things. But if we were face to face, I'd have 3 hours to let students take the final, because ECC really doesn't have a finals week. I don't know why they never did, but they don't. But I have found in face to face, most students are done within 75 minutes to an hour and a half. My finals, it's like my test. If you know it, you can do it. If you don't, well, that's another story. I hope none of you are in. Now, this, like all exams I've given this semester or tests, will not be an open note or ask anybody or get help from the internet. Now, let's talk about the final exam, and take a deep breath. I'll explain this in a second. It has 32 problems, 18 pages. Relax. Some of the problems are multiple part. Now, I have the point breakdown 2 different ways. First way, general knowledge, 30 points, nomenclature, 62, reactions, 118. If you notice, it adds up to 210. That means there's 10, 10, count them, 10 bonus points. Now, another way to break it down is material from test 1 is 35 points, from test 2 is 60 points, test 3, 58, test 4, 54, and new material, proteins and amino acids, 4. Now, you might want to ask, how come only 35 points on test 1? Well, by now, I think you figured out how to find how many carbons are in the longest chain. and things like that, that I don't have to ask ever again, because you use that for test 2, 3, and 4 material. Now, I'd recommend that you download the final exam and instructions if you need it, how to take it. On next Sunday, I'll have it on D2L. And if you haven't already this semester, which I don't think you really have to, but practice making your PDF file. All right, if you have any questions during the test, we will not have a Zoom meeting. You'll be taking the final exam on that Monday. Email me. And same thing Tuesday morning. And like I said, there'll be no Zoom meeting lecture. And I'll be posting the final exam score along with, listen carefully, your final Chem 170 grade in D2L by Sunday, the end of that next week, a week from this Sunday, or hopefully a lot earlier. You're taking on Monday. I would hope to have it done by Wednesday or Thursday, maybe even Tuesday, but I don't know about that. But, well, you're not going to hand it in until maybe Tuesday. So probably Wednesday or Thursday, I'll have it done. For sure, I would hope by Friday. But, you know, life always throws curves at you. Like I said, this week, today and Wednesday, I'll be doing a review of the whole semester, which helps my students and hopefully will help you. Now, when you look at that and say, oh no, 18 pages, well, it's the same length as 2 of my tests. It's a final. However, I can tell you this. Over the years, and it's always amazed me, well, maybe it shouldn't, because I've been blessed. I get good students. I don't know where they come from, but I get them, thank goodness. And that is average on my final out of 210 points is usually 87 to 90%. That would be the same as getting a 90 on one of my hourly exams. That's about what the average is. And that's including both online and before the pandemic, face-to-face. So if you study, you'll do good on my final. Am I going to use the same questions on my hourly exams? No. But are they going to be similar? Of course. Just like the questions from my practice problems are similar, but not the same as with the hourly exam questions, but they're similar. My advice to you is, one, watch what I'm doing, the reviews, and you can do it too on your own. They're available on D2L. And the other thing is, use your hourly exams, exam 1, 2, 3, and 4, as practice problems for the final. Use those as practice problems, and they'll help you. And this is what I've told over the years, and students do well. I hope you do well too. Any questions? All right, couple things. I just noticed on Zoom, they do something strange because they don't allow me to set up meetings that are like Monday and Wednesday. It's like once a week. It's strange. So they only let me set up one meeting for 50 times, and this Wednesday will be I believe my 50th time. So what I probably will have to do for next week's office hours, and also set up in case there's reason I need it, I'll be setting up a new Zoom meeting, and I'll send out the link, and the password I'll keep the same as this course right now. So that's just a slight change, and I'll change it on D2L. Next week, there'll be no Zoom meeting on Monday. Tuesday night, I'll have my office hour. Not that there's anything, if you want to stop by, say hello, feel free to. And Wednesday, because I couldn't get any other time, I have a doctor's appointment at 1:30 on Wednesday. And so I'm going to be holding, I'll put out an email, the class lecture, which you don't have to show up, on Wednesday at about 11:30 for a half hour. And in real life, if we were face to face because of the contract, technically for a net class, I don't have to, but I will. But if we were face to face, I'd have to show up for my class after 15 minutes when nobody shows up because you're done. And I don't expect anybody to show up. I leave because if nobody shows up after 15 minutes, nobody's going to show up and I'll leave. I will have my office hour Wednesday night if you want to stop by and say hello. And with that, any questions? All right, let's get going. Let's go through what I'll do quiz, test 4, and then we'll start the review. Let me close that first. I will cut those answers out of the video. I just don't want them floating around the internet for all time when I give similar tests. Even though you've got copies of tests, when I'm face to face, I give back copies, which is why I rewrite my tests every semester. All right, important thing you probably are wondering. What's my grade right now? Or really, how many points do I need on the final to get my grade that I want? Let's go through this. Now, this is assuming you've handed in all the labs and you've gotten good scores. If you've handed in the labs, I think almost everybody's gotten good scores. All right, let's look at the following. Now, you take the sum of your 3 highest test scores, and if you look on black, wrong school, D2L, this is now posted there. And you add to that, if you did, the points you got for your extra credit. And you'll get a number I'll call X. This assumes you've handed in all your labs. If not, then you got to do the long way, which I don't like doing. To get an A, it's 450 minus X. Those are equal to the points needed. And for B, it's 400 minus X equal the points needed. For C, it's 350 minus X. And for D, it's 300. Hopefully nobody's in there. Now, this is assuming you've handed in all the labs. You haven't, then that's going to affect this. But over the years, this has worked well. Let's assume, and I'm Dr. White's being real lazy, say you had 3 100ths on 3 to 4 tests and no extra credit. So your sum X equals 300. Or to get an A, 450 minus 300 equals 150. Now you see that number and say, oh no, 150, that's a lot of points. No, it's 210 on the final. Now, a way to give you a peace of mind, if you were to divide this by 2, you get 75, which is like if you took an hourly exam, what you would have gotten. If you have any questions about this, feel free to email me or stop by my office hour. Or if you can't stop by my office hour, let me know and I'll see if I can set up a Zoom meeting for you. Any questions on how to figure out how many points you need on the final exam to get the grade you want? Now, remember, this is based on you've handed in all the labs. If you're missing a lab, I'm going to let you hand it in late, but I'll take off 3 points for being super late, 2 or 3 points. All right. Now, one note of caution. Over the years, I've seen students do this, and they say, oh, I only need to get like 140 points or 70% on the final. And they don't study, or they don't study hard. And guess what? They do badly on my final. It's rare, but I've seen it happen a number of times. And then they lose what they should have gotten this grade. They'll get 1 and 1 time, even 2 letters lower than they should have done if they've studied a little. So even though you don't need a lot of points on the final, percentage-wise, study like you need every point. Okay? Any questions on this? All right, what I'm going to be doing, before I forget, and I'll mention this at the end, and I'll put up this Wednesday, I've got a special surprise for all of you, but you have to come to our Zoom meeting because I'll be cutting it out of the video. I like my special effects. But anyways, that reminds me, quick Dr. White story. When I was in undergrad in our fraternity, we had this one fraternity brother. We were cutting out things for a party or anything. Whenever he'd be doing a scissors, his mouth would keep pace with how he was cutting. He'd go like this. I don't know if I can do it. Whenever we use scissors, he'd do that. We gave him a lot of grief for that. Fun grief, but it was funny. All right, my special gift to you this Wednesday. I will take you via pictures inside a chemical plant. Almost most people in the world have never and do not allow to see the inside of a chemical plant. Visitors are not allowed to take pictures, either are employees. How did I pull it off? Well, you'll have to wait until Wednesday for that story. But you'll get to see the inside of a chemical plant where I did reactions, supervised reactions, anywhere from 120,000 pounds to 180,000 pounds. You've ever seen one of the tank wagons that deliver gasoline to a gas station? That's 40,000 pounds. So I'm talking anywhere from 3 to almost 4.5, 5 of those. That's a lot of chemicals. It's a lot of fun. It's also a lot of pressure because you're dealing with a lot of money. And if you mess up, you get fired. Never happens to me. All right, let's get going. And let's go through the whole semester, starting at test 1. You should know, what are hydrocarbons? Hydrocarbons are molecules with only carbon, hydrogen atom. Remember, these reviews are available to you on D2L, cleverly hidden in the lecture section. And this one has the clever hidden title, Test 1 Review. You should know saturated hydrocarbons are molecules with carbon and hydrogen, which have all carbon-carbon single bonds. And unsaturated hydrocarbons are molecules with only carbon and hydrogen atoms and have at least one carbon-carbon double bond or triple bond. That's where the unsaturation. It comes from the idea you can put more hydrogens in it if you hydrogenate a double or triple bond. It's not fully saturated with hydrogens. All right, I won't ask you, but we talked about alkanes, acyclic saturated hydrocarbons, and cycloalkanes, acyclic saturated hydrocarbons. This should be cyclic. Yeah, mistake. Sorry about that. All right, now you should know how to draw alkanes and cycloalkanes with the hydrogens. On the final exam, your friend will be how many bonds to carbon? Oh, I got to get this fixed one day. How many bonds to carbon? Four bonds to carbon. Remember, on the final exam, that's one of your two friends. The other one, which I'll mention again, is the break carbon-carbon single bonds. No, so don't. Now, I showed you how to draw that, and we started with the IUPAC names or rules, which are the nomenclature rules. And I'll never ask you, but remember, nomenclature means how to name. And I won't ask on the final for the actual, like we did in test one, but for other nomenclature, you have to know how to find the longest chain to get the root name. Now, for alkanes, you should know the alkanes 1 through 10, 1 carbon, methane, 5, pentane, 7, heptane, and so on. Then I talked about alkyl groups. And the key alkyl groups, CH3 on something is methyl. 2 carbons, ethyl. 3 carbons, they're 2 different alkyl groups or substituents. To the N carbon is N-propyl, center carbon isopropyl. And finally, I only asked you to learn 2 of the 3 possible 4 carbon alkyl groups. And when it's 4 carbons to the N, it's N-butyl. One of my favorite, I like isopropyl too, but when it's 4 carbons, 3 CH3 to center carbon, that's bonded to your ring or longest chain, that's called a tert-butyl or T-butyl. And you should go back and review these. Now, for this one chapter, as I did in other chapters, I asked you to learn about real-world uses. And where do you find alkanes? Natural gas, methane, propane for your barbecue, gasoline, Vaseline, I think I spelled that wrong, and baby oil and candles. Those all contain alkanes. I gotta ask, it's the last week. Did any of you happen to think of alkanes when you drove by a gas station? I hope so. This is my last week I can ask you that. All right, now, in this class, you learn we don't balance chemical equations. We're just interested in the products. And therefore, alkanes, I could have also put down there cycloalkanes. Since I wrote this with my software, I'll have to write it up here. And if we take a alkane oxygen, you get carbon dioxide and water plus heat, but heat is not a product, chemical product. And I taught you the chemical instructor, organic chemistry instructor's trick on a test, and that is put a big scary molecule. And the question would be, what are the two products or products for that reaction? I'm going to let you have some fun. What are they? If you remember on test one, I asked a similar problem, 4 points. And when you're done, give me a thumbs up. Thank you, Andrew. And a word of advice to all of you for the final, don't forget, use the method. All right, let's take a look at this. I think everybody's done. And what do we have here? An alkane. Could have been a cycloalkane. Plus oxygen, general reaction, you get CO2 plus water. Guess what? You get CO2 plus water. The key thing is to look at a molecule and see what's different. Well, in this case, there's only carbon-carbon single bonds. So, and hydrogens, it's an alkane. Next, I talked about alkenes and alkynes. Now, I didn't go through just now how to do the IUPAC name, but I think I better do something important before we get into double bonds. Give the IUPAC name for the following. What's the longest chain? Oh, we've got a ring. How many carbons in a ring? Remember, a ring, every bend in a line is a carbon. 5, that would be pentane. It's a ring, so don't forget, students do, cyclopentane. And then 3 carbons, N-carbon is N-propyl. And when there's only one alkyl group, you don't put a number, because any carbon on the ring, when there's only one group, would be carbon number 1. So it's N-propyl cyclopentane. Now, just to remind you, what's the longest chain? 1, 2, 3, 4, 5. Pentane. And this is all spoken for. And when you're numbering the alkyl groups, notice we have 2 CH3. Oh, it's your old friend now, the methyl group. And when there are 2, that's di. And tri is 3 groups. And you number from the side to give the alkyl groups the lowest number, 1, 2, 3. And when you see di, that means you need 2 numbers, even if they're on the same carbon. And this would be 2,3-dimethylpentane. Now, let me remind you that when you're, I lost my train of thought. It went, hold on, let me look at the example. Oh, now I got the train came back to the station. But anyways, when I talk about nomenclature problems, there's two types. Here's the structure, give the IUPAC name, and the other is here's the name, draw the structure. And if I look at it, wow, time flies when you're having fun with Dr. White and organic chemistry. Let's take a 5-minute break, and I'll see you in 5 minutes. I can get up and stretch. I'm back. Hopefully you are too. All right, let's get going. Now, let's continue on test one review. We have alkenes are double bond, and double bond is made up of one pi bond and one sigma bond, single bond. And you have an alkyne, which is a triple bond. 3 lines show you triple bond, 2 lines double bond. And you should know a triple bond is made up of 2 pi bonds and 1 sigma bond. Now, how do you name them? For alkenes, a double bond, ane ending, you find the longest chain with both carbons of the double bond, name it as an alkane. Change the ane ending to ene. And then you need a number, which carbon, for acyclic, plus if it's cis or trans. If it's in a ring, no number, because one of the carbons of the double bond in a ring will always be 1. There are no other functional groups in the molecule, which is how I kept it this semester. Now, for a triple bond, you have ane ending, find the longest chain with both carbons of the triple bond, and then you drop the ane, replace it. That's a mistake. Oh no. It should be yne and the number. Now let's do an example of a double bond. All right, now, as I taught you this semester, when you're looking at an organic molecule, look for what's different, what's not carbon, what's not hydrogen. Should get your attention like that. That gets your attention. How about like this? Anyways, double bond. How many carbons in the longest chain? 1, 2, 3. Even though you show angles, they're connected together like a chain, linked together. 4, 5, 6, 7, 8. Longest chain is octane. It's a double bond. Drop the ane ending, put in ene. Now, for a double bond, when they're on opposite sides, hydrogen for this class is trans. When they're on the same side of a plane, this is cis. So they're opposite. So this is trans. But what carbon is the lead carbon of the double bond close to the end? So it's 2, and it's trans. And then we have right here your old friend, the methyl group. And it's on carbon 5. So it's 5-methyl trans 2-octane. Remember, trans hydrogens on the opposite side, cis, they're on the same side. And forgive me. No, you don't have to forgive me. Everybody know what that is? Transparent. Ooh. Transparent, never mind. All right, now, at this point, I started teaching you general reactions that for a molecule with this functional group always undergo. If we look at the first one, hydrogen and a catalyst with a double bond, you break the pi bond and each carbon gets a hydrogen. And the catalyst can be nickel, platinum, or palladium. Remember, everything you see is in D2L in the lecture section. In this case, I'm in review for test number 1. If we look at this reaction, the question will be, give the organic product or products. And what's different? A double bond. And you're reacting with hydrogen and a catalyst. Everything else stays the same because you don't break carbon-carbon single bonds. General reaction. You have a double bond. Remember, 1 pi bond, 1 sigma. You break that, and each carbon gets a hydrogen. Do you break carbon-carbon single bonds? No. So I have 1, 2, 3, 4, 5 across. I better end up with 5 across. On this carbon, I have this methyl group. It better still be there. Now, what changes is on these 2 carbons, you break the pi bond, and each carbon gets a hydrogen. And now you know there are 4 bonds to carbon, and you can fill in the rest of the hydrogens. I wanted to show you this to remind you, you don't break carbon-carbon single bonds. That's your second friend on my final exam. First one, there's 4 bonds to carbon. Second one, do you break carbon-carbon single bonds? No. Other types of bonds, yes, but not those, other than combustion, which I just showed you. All right, other reactions you should know. You take a double bond and react it with halogen gas. Remember, X is abbreviation for fluorine, chlorine, bromine, or iodine in this example. You break the pi bond, and each carbon gets a halogen. And these 2 are symmetrical addition. You add the same thing to both carbon of the double bond. Now, if you have unsymmetrical addition, like this reaction right here, you have a double bond, you're adding HX, where X now is chlorine, bromine, or iodine, not fluorine. You break the pi bond, 1 carbon gets H, the other gets X, and it follows Markov-Nikov's rule. And let's talk about Markov-Nikov's rule. That's a better HCl. All right. So the question is, what's the product or products of the following? What's different? What's not carbon? What's not hydrogen? A double bond. We're reacting with HCl, which is HX, where X can be chlorine, bromine, or iodine.
Dr. White, I think we're still on the general reactions page.
Oh, no. Thank you for letting me know. You're right. Am I turning red, blushing with, oh, I've kept my mistakes to minimum. I try to. All right, do you see it now? Thank you for letting me know, Christiana. All right, so we have this molecule reacting with HCl. Now you can see it. And what's the functional group? a double bond. Reacting with HX, X is chlorine, bromine, or iodine, in our case, chlorine. You break the pi bond. Remember, there's one pi bond, one sigma bond. One carbon gets H, the other gets X, and it follows Markovnikov's rule. Almost wrote it, and I don't know if all of you know how to read cursive. But anyways, let's look at the specific example. You break the pi bond. Now, what's Markovnikov's rule? The hydrogen from HX goes to the carbon with the most hydrogens on the double bond. Hold on. I keep on getting these junk calls from this one call number today. I don't know what they want me to buy, but I'm not. While it's ringing, I'm going to take some water. Two more. Hopefully no more. My voicemail picking it up. They're not going to leave one. Anyways, Markovnikov's rule. Look at the two carbons of the double bond. The hydrogen from HX goes to the carbon with the most hydrogens, and the other carbon gets the halogen. This has two carbon hydrogens. This has one. Got to use your highlight. Wasn't the math hard this semester? I mean, really hard. Which is the larger number? Hopefully I'll pick 2. So the hydrogen goes here, the halogen goes here, and you know there are 4 bonds to carbon. And you can put in the rest of the hydrogens if I do it correctly. That's 8. Hold on, let me clean that up. If you wanted to write this CH3, you could, but you don't have to, because I'm the one grading the final. All right, remember, for Markovnikov's rule, the hydrogen goes to the carbon in the double bond that has the most hydrogens on it before it reacts. And another example would be double bond reacting with H plus. Remember, H plus I've used this semester means an acid catalyst. And water. Think of water as H and OH, and you break the pi bond. One carbon gets H, the other gets OH, and it follows Markovnikov's rule. Now, for triple bonds, I just asked you, excuse me, why itch. Sorry about that. Well, anyways, a triple bond has 2 pi bonds and 1 sigma bond. And when you do hydrogenation, so we don't have to balance the equation. Did I tell you organic chemists are lazy? We are in certain aspects. I'll put bracket X, S, close bracket, and that tells me I have all the hydrogen in the world that anything that can react with hydrogen will. That's 2 pi bonds, and for each pi bond, each carbon of the triple bond gets a hydrogen. For 2 pi bonds, each one gets 2 hydrogens. And the same thing for halogenation. You have 2 pi bonds and 1 sigma bond. And just like you learned with a double bond, each halogen molecule, X2, will break a pi bond, and each carbon of the pi bond gets a halogen. 2 pi bonds, each carbon of the triple bond gets 2 halogens, and here X is fluorine, bromine, chlorine, or iodine. Next, I think I mentioned you can see double bonds in carrots and tomatoes. The color of carrots and tomatoes are due to double bonds. Anybody happen to look at a carrot and think about alkenes? All right, next I talked about aromatic compounds, and the 2 key ones are benzene and toluene. And benzene is a six-membered ring with three conjugated double bonds. That means alternating double, single, double, single, double, single, as you see here. And there are different ways you can write it. This one is other resonance form, or the one I don't like, but you can use is with a circle. In fact, over here, I forgot to do it with a circle for toluene. Now, here, I should have done right here. And IUPAC, like I said, in their infinite wisdom, the name benzene has been around for eons for this molecule. Now, when you have a methyl group on a benzene ring, that is not methyl benzene, it's toluene. Now, important thing, if I ask you to draw the structure of benzene, don't forget the double bonds or the circle. If I ask you to draw the structure of benzene, or if you're doing chemistry, don't forget those bonds, because otherwise it's cyclohexane. That's a common mistake on test one and the final. Remember, this could be a nomenclature, and I think I did ask this on test one. And the right answer would be this is one resonance form, or another resonance form, or the delocalized like this. If you were to draw this, it's cyclohexane. So when you're drawing structures of benzene or toluene, don't forget the bonds here, like here, or the circle like that. Now, when it comes to di substitute, remember, di means two groups of benzene or toluene. The methyl group counts as one. We use not numbers, but ortho, meta, and para. And ortho would be 1,2 disubstituted, meta would be 1,3, and para would be 1,4. And at this point, I taught some new substituents. The halogen Cl is called chloro group, F is fluoro, and Br is bromo, and I is iodo, plus one new group totally, NO2, nitro. Oh, let's get this right. Now it should work. And the question would be, what's the IUPAC name for this? And notice you have a benzene ring, but it has a methyl group. Cl is chlorine, which is called the chloro group. Notice the methyl group is 1, 2, 3. This is 1,3 disubstituted, which is meta. So this would be meta chlorotoluene. If you had a benzene ring with disubstituted, you'd use ortho, meta, and para. Remember, ortho 1,2 disubstituted, meta 1,3, and para 1,4. I've got to. Sorry about this. Everybody know what that is, and it won't be on the final. Paramedic. 1,4 paramedic, never mind. All right, now, when it comes to aromatic compounds, you do not break the double bonds in the ring. You do not, because that gives it a lot of extra stability. What you do is replace one of the hydrogens on the ring with something else. And as my gift to you this semester, I did not teach you about, other than the lab we did, which the lab stuff never comes into the lecture test or final. I taught you about directors. But because I don't want you to spend the time on directors, there are other things I'd rather spend time on this semester, more important to you. And that is, I only had these reactions. If you take benzene, react with halogen and ferric trihalide, where X can be chlorine or bromine, that's real life. I've never seen it anything else. And you replace one of the hydrogens with a halogen. Pay attention. Next one, benzene ring, HNO3 is nitric acid, H2SO4 is sulfuric, and this replaces the hydrogen with an NO2 group, nitro. Common mistake students put here, NO3, and that's wrong. It even says it on the screen, and that was bad. And finally, another one, not finally, if we react the benzene ring with sulfur trioxide and sulfuric acid, you put on a sulfonic acid group, SO3H on a benzene ring. Don't forget to write the double bonds or circle in the ring. Otherwise, that's cyclohexane, and I mark it wrong. And I've had students on the final or test one forget to do that, and I give them 0 points because I warned you. Now, finally, the last one, and that is Friedel-Crafts alkylation. This is one of those special reactions where you make a carbon-carbon single bond. Very special, very rare. And here you take an alkyl halide. Remember, R at this point I taught you was anything with carbon hydrogens. Could be 1, it could be 5, it could be 1,000,000. Probably isn't in this reaction, but it could be. And you take aluminum trihalide. And you replace a hydrogen with the R group, and the carbon with the halogen is the carbon the benzene ring is bonded to. And here, if we have what's the product or products for the following, you identify what you have that's different. Ooh, a benzene ring. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention like that. And if we look at the second thing we're reacting, carbon, 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 halogen, alkyl halide, where X can be chlorine or bromine. And here we have a catalyst, aluminum trihalide. And this is Friedel-Crafts alkylation. I'll never ask you names of reaction on my final. And what's my R group? 4 carbons. Of my benzene ring, don't forget the lines are circle, bonds are circle. Which carbon has the halogen? The end one. Do you break carbon-carbon single bonds? No. So I have 4 carbons. I know there are 4 bonds to carbon. So I can do this. Now, on the final exam, I have a number of synthesis problems. I don't remember how many, maybe 5 or 6. But what's a synthesis problem? And I'm about to sneeze, so hold on. Excuse me. Oh, slow rolling sneeze. Wow, it was in slow motion. But anyways, let's get back to class. And question is, what would be the 2 starting materials reacting with aluminum trichloride to make that molecule? I'm going to let you have some fun. Your turn. All right, I think everybody's done. I don't know, Andrew, did you do it and I missed, or are you not done yet? He did it? All right, I missed it. All right, my turn. And that is, what would be the starting material? What's different here? Ooh, a benzene ring, but it's got an R group. I have, aluminum trihalide, and this is Friedel-Crafts alkylation. Take benzene plus RX. What's my R group? Isopropyl. So one of these would be benzene. Now the carbon bond to benzene, in this case center, is the carbon with the halogen. So that would be like this. And the halogen here, chlorine, and that would definitely give you the right product. And you should know how to do this. We practice this type of synthesis all semester. And that's it for test number 1. Let's move on to test number 2 review. And now we started getting some really good stuff. And the first one was a new functional group, and that's alcohol. And alcohol is any molecule that has a carbon, R group, with a hydroxyl group, OH. And how do you name it? You find the longest chain with the hydroxyl group carbon. Name it as an alkane or cycloalkane. And you drop the E and add OL. And if it's acyclic, you need a number, and that's always the highest priority, lowest number. If it's cyclic on a ring, no number, because that carbon, if there are no other functional groups, and that's how we've done it this semester, will always be 1. I like these special effects I'm pulling out today. Now, there's a special molecule, and that's, let me write a better one. A benzene ring with a hydroxyl group is not called benzol, even though students write that down and I mark it wrong. It's phenol, or some people pronounce it phenol. No, it's phenol. Now, I asked you to learn some common names. And common names, remember an alcohol, hydroxyl group on R on carbon. For common names, you name the R group as the alkyl group and then add the word alcohol at the end. And remember, rubbing alcohol is 70 to 90% isopropyl alcohol, the other percent water. You can buy both 70 and 90% rubbing alcohol, meaning how much isopropyl alcohol, at any of your local big box stores like the French store my friend likes to go to, Target, that's his favorite joke, or Walmart. And here, isopropyl group, it's an alcohol. Nobody calls this 2-propanol. It's gone by isopropyl alcohol. Now, synthesis, how to make an alcohol. Well, we've shown this is the only reaction the whole semester. I put on 2 tests, double bond acid, water. You break the pi bond, one carbon gets H, the other gets OH, and it follows Markov-Nikov's rule. And that is the carbon of the double bond with the most hydrogens gets the hydrogen, the other gets the hydroxyl group. Now, next, I talked about one of the more challenging reactions this semester, and that is dehydration of an alcohol. That's sulfuric acid, H2SO4. The little triangle means heat. And you lose water, form a double bond, and it follows Zasev's rule. Heat, and sometimes I'll put a number there like 180 C, showing you, wow, that's pretty high heat, 180 degrees centigrade, Celsius. I mean, I use the old name, and it's still in my brain. But anyways, in a chemical reaction, you crank it up that high, that's high heat. And the question is, what's the product or product? Now here, what's different? Ooh, an oxygen with a hydrogen and a carbon, alcohol. An adjacent carbon has a hydrogen, H2SO4, heat. You'll form a double bond plus water, and this follows Zasev's rule. And what's Zasev's rule? You'll get the product that has the most carbon atoms directly bonded to the carbons of the double bond. The way I do it, it's actually the major product, but to make your life easier, I just make it the only one. Now, if we look at this, here's our car with the hydroxyl group. And right here, what? Yeah. What did I? Oh, that's why. That's better. We have 2 adjacent carbons with hydrogens. Now, my general reaction, you lose from the carbon with the hydroxyl group, you lose a OH, and the other carbon of the adjacent carbon, hydrogen, and between those two, you form a double bond. So if I lose the hydrogen from A, the hydroxyl group, this is the product I get. if I lose the hydrogen from B in the hydroxyl group, this is the product I get. Now, Zayseff's rule is the product that has the most carbon atoms directly bonded to the carbon of the double bond, carbon's double bond is the product you get. If we look at A, this is the only one. That's carbon atoms directly bonded to the carbons of the double bond. If we look at B, these are the carbon atoms directly bonded to it, and that would be 3. And now you use your high-level math skill, which is the greater number, 3 or 1, and time's up. Hopefully pick 3, and this is the answer, B. And that's how you do Zayseff's rule. Now, as my gift to you during test 2 and also final, I will never, ever give a synthesis problem with Zayseff's rule. That's not fair. And you know by now, hopefully you think I was fair this semester. Speaking about fair, public service announcement from Dr. White. You should have all received an email with, I think it's a link to do online evaluation of me. And please fill those out. I will ask you 2 other things. One, if you really like what I did this semester, besides filling that out, go to ratemyprofessor.com and write something about me. If you really didn't like what I did this semester, go to ratemyprofessor.com and write something to me. Now, if you really, really like what I did this semester, send an email to Dr. David Sam, the president of ECC, wrong school, right person, but wrong ECC, and copy the board of trustees. And sometime this week, I'll send you an email with his email address and the board of trustees. And if you really, really didn't like what I did this semester, send an email to Dr. David Sam and copy the board of trustees. Up to you, but I'd appreciate if you do at least go to ratemyprofessor.com if you really like what I did or you really didn't like what I did. And that's my commercial for today. All right, let's move on. Some simpler reactions. You take an alcohol, react it with HX, where X can be chlorine, bromine, or iodine. You replace the hydroxyl group with the halogen on the carbon that has the hydroxyl group. If you take an alcohol and react it with SOCl2, thionyl chloride, you replace the hydroxyl group with chlorine. Now, as I showed you, which I'll never put on the final, the second reaction, SOCl2, was developed because there's a double bond, sometimes HX will, in the alcohol, and the alcohol plus HX could react with that, and you get a mess. And if you had a double bond, which I won't do, use thionyl chloride. Both are on the carbon with the hydroxyl group. And to your turn, what would be the product or products for the following reaction? All right, everybody's done. What do we have that's different? Ooh, oxygen got my attention. On a carbon, this is an alcohol. I'm reacting it with thionyl chloride. Replace the hydroxyl group with a chlorine on the carbon that had the hydroxyl group. Do you break carbon-carbon single bonds? No. So I have 1, 2, 3, 4. The OH is replaced with a chlorine. I know there are 4 bonds to carbon. And that's what I get. Next, I talked about primary, secondary, and tertiary alcohols, which I will never ask you on a test. And here we have a primary alcohol that's one R group on a carbon. If you react it with an O in a bracket, closed bracket, is an oxidation reagent. And there are many, and I didn't ask you to learn them. Just use the abbreviation bracket O, close bracket. There's a hydrogen here, hydrogen there, form a carbon-oxygen double bond, and you get an aldehyde. If you have a secondary alcohol, 2 R groups on the carbon with the hydroxyl group, same thing happens. Remember, you don't break carbon-carbon single bonds, so the R groups come along for the ride, and you form a carbon-oxygen double bond again, and this is a ketone, which I taught you later. What would you oxidize to make that compound? Your turn. Thank you, Christiana. Thank you, Andrew. And seriously, thank you both for coming to lecture all the time. It's good to have live people to talk to. All right, what do we have that's different? What's not carbon? What's not hydrogen? Ooh, oxygen, double bond to carbon with a hydrogen on that carbon right here. And carbons are, this is an aldehyde. And what do you oxidize? A primary alcohol. And here's this carbon, which becomes this carbon, which I taught you later on, was the carbonyl. My R group is isopropyl. Then I have CH2OH. I know there are 4 bonds to carbon, so I can put in the rest of the hydrogen. Anybody having nightmares? Me going, how many bonds to carbon? I hope not. All right. Let's move on. Now, a special functional, not special, functional group R with a sulfur or a hydrogen, it's called the alcohol analog, because similar, the only difference instead of oxygen, you now have sulfur. And these are called thiols. And you should know, they stink. And as I told you, that sad story about the explosion back in about 1935 and the deaths of many students and teachers at that one school in Texas, thiols, which are stinky, are put into natural gas so you can smell a leak. Methane, natural gas, is odorless. And then test number 2, I asked that question. Now, next I talked about ethers. Ethers are where you have an R group, oxygen, R prime. And an ether is used a lot in organic chemistry, certain ethers as solvents, and the one ether, which I talked about, actually more than one now, but back in 1800s, was found to be an outstanding inhalation anesthetic. That's diethyl ether. Now, I didn't ask you to learn IUPAC names for ether, but name R group as the alkyl group, each R and R prime, and add the word ether. Can you keep a secret? I've never asked on a final, what's the name or nomenclature of ethers? Shh, I didn't tell you that. For those of you watching and those of you who came today, that's my special Monday gift to you. But I did ask and will ask, how do you make ethers? And that's the Williamson ether synthesis. That's where you take an alkoxide, RO minus, Na plus, with an alkyl halide, where X can be chlorine, bromine, or iodine, and you form an ether plus a salt. And the question would be, what's the organic product or product for the following? And how do you do this? And I'll show you this one because we're running out of time before our next break. What's different here? Carbon on an oxygen on a minus, sodium cation, alkoxide. And unfortunately, I didn't have time to teach you the nomenclature for alkoxides or anything else. And what do we have here? Carbon, ooh, halogen, alkyl halide. And remember, X can be chlorine, bromine, or iodine. And this is Williamson ether synthesis. It attacks the carbon with the halogen and knocks out the chloride anion to form an ether. Now, I'm going to write it down, but you don't have to put it there except for synthesis plus a salt. What's R? Methyl. What's R prime? Isopropyl. Which carbon has the halogen in the center? Do you break carbon-carbon single bonds? No. So my R prime is this. I'll have my oxygen. And what's my R group? Methyl. I know there are 4 bonds to carbon, so I can put them in. And you form methyl isopropyl ether. I don't think I mentioned this, but a very important ether that has this structure where it's 4 carbons and an oxygen, that's called tetrahydrofuran. And I used a lot of it in graduate school for my research as a solvent. In fact, I had to purify it, and other people in our group that we had a sill set up that we made it so there was no moisture in it at all, 0. And I worked under argon atmosphere to keep moisture out for my experiments. Fun. Now, the next thing I talked about was epoxides. And epoxides at first glance looks like a ether, but it's not. Oh no, I went a minute over into our break. Let's take a 5 minute break, come back at 5 minutes, about 5:52, and I'm gonna get up and stretch some more. I'll see you in 5. Time to get going again. All right, let's continue. Now, we're talking about epoxides. And epoxides are the key one I talked about was ethylene oxide, which I'll never ask you on a test what's its name. But if you take an alcohol and react with ethylene oxide, you form this ether alcohol. And the carbon with the hydroxyl group in the alcohol will be the carbon with the oxygen here in the ether alcohol. Now, if you react more than 1 mole or molecule of ethylene oxide with an alcohol, you get this polyether alcohol, where N comes from the coefficient, the number in front of ethylene oxide. And remember, the hydroxyl group is on the outside of the bracket. Common mistake on the final exam, students put it inside, and I mark it wrong because you can't. And remember, at this point, I started getting into interesting things where you find molecules made with these reactions. And I talked about how to make the spermicide, nonoxyl 9, found on lubricated condoms. But you never thought all the neat stuff I can get into. And here's one for you to try. What would be the organic product or products for the following? And one of the things I'm doing in the review, I'm not going through a lot of nomenclature examples, but I think by now most of you have gotten nomenclature down pretty good, other than double bond cis and trans. Thank you, Andrew. Thank you, Christiana. My turn. And what's different in this first molecule? Oxygen with a hydrogen and a carbon. It's an alcohol. Then you have, ethylene oxide. This is very dangerous stuff to work with, but I've worked with it both in a lab and in a plant supervising. And we have N moles, and you make this polyether alcohol. What's this ring with a methyl group? Do you break carbon-carbon single bonds? No. So it's still going to be a ring with a methyl group. And this carbon, we now have this, which would be bracket OCH2, CH2. What's N? 8, and then OH. Remember, the OH does not go inside. And that's how you do it. Now, as I did on test 2, I'll do on the final. For these two reactions with ethylene oxide, I will never give a synthesis problem because that's cruel and unusual punishment. I think it's still outlawed by the Supreme Court. I don't know, that might change in the future, but I won't. All right, so I will not give synthesis, but I will ask you to predict the product or products. And now we get into some good stuff, because this is one of Dr. White's favorite functional groups. As I mentioned, I have comfort functional groups when I'm not feeling good, like blue, and you know how you get. I think about aldehydes and ketones and their chemistry, and I get happy. Now, What's an aldehyde? An aldehyde is a carbon double bond to oxygen with a hydrogen and carbons on that carbon. Aldehyde. What's a ketone? Carbon double bond to oxygen with R and R prime. Carbons on that. Now, for aldehydes, find the longest chain with the carbon double bond to oxygen called the carbonyl carbon. Let me do this first. Ooh, it's in red, so you better know that. And I asked on test number 2, this is probably one of the most important things to me in all of organic chemistry. What's the carbonyl group? You should be able to draw the carbonyl group, carbon double bond to oxygen, and describe with words what is the carbonyl group. Carbon or carbon atom, double bond to oxygen, or you could put down oxygen atom. And if you go back, you'll see this was 4 whole points on test number 2. Is that important? I even did it in red. Did I tell you what my favorite color is? I think I did. But in case you're wondering, this is above my monitor. In case you're wondering, it's red. And when I do something red, it's important. So you should know carbonyl group, carbon, double bond to oxygen, how to draw it, how to describe it with words. And if you look at an aldehyde and ketone, they both have a carbonyl group. For an aldehyde, you find the longest chain that has the carbonyl group in it and name it as an alkane, drop the E, add Al, no number, because the carbonyl carbon is always number 1 in an aldehyde. And you name the rest of the alkyl groups the way you already have. For ketone, you find the longest chain with the carbonyl carbon, drop the E, add ONE. If it's acyclic, not in a ring, you need a number what carbon that is, and it gets highest priority, lowest number. If it's in a ring, no number, because that carbon will always be number 1, because carbonyl carbons rock. They're cool. All right, let's do 2 quick ones. What would be the IUPAC name for that molecule? And one of the reasons Dr. White students do good on my final, 1, they know to use their tests as practice problems. And 2, I know those of you who watch the video or show up to class, when we're face-to-face, people show up to class because I take attendance. And I can't do that on a internet class, and I don't. But you get about 4 hours of 5 hours of study with Dr. White for the final, which can only help, and it does. All right, what's everybody done? Thank you, Christiana. Thank you, Andrew. What's different? Carbonyl. It's got a hydrogen carbons. It's an aldehyde. How many carbons longest chain with the carbonyl carbon? 1, 2, 3, 4. 4 is butane. Drop the E, add Al. Remember, be careful, your Al and OL. OL is alcohol, Al is aldehyde. No number because the carbonyl carbon is 1. And on carbon 3, it's your old friend, the methyl group. Ugh. That's an ugly looking 3. Let's try it again. That's better. 3-methyl butanol. Let's do another one. And here's another one. What would be the IUPAC name of that molecule? Oh, I forgot to mention, don't forget, where can you find alcohols in your daily life? Well, if you drink beer, wine, or hard spirits like Dr. White's favorite, vodka, good vodka. And also I like Canadian Club. And this time of the year, what's it called? I can't think of the name right now. I got a mental block. But Amaretto. I love that too. All right. No, I'm not an alcoholic, but I still like my good stuff. All right. So what do we have here? Oh, I said about where alcohols are. And don't forget, you can find alcohols in rubbing alcohol. Would I ask a question like that? I did, test number 2. So what do we have here? We have everybody done? Okay. We have a ring. What's there? Ooh, oxygen, double bond to carbon. And this is a cycloketone, where R prime and R double prime, or R prime and R, are connected together. How many carbons in the ring? 1, 2, 3, 4. I lost count. 1, 2, 3, 4, 5, 6. Hexane. Remember, it's a ring, cyclohexane. Hold on. Drop the E, add ONE, because it's a ketone, cyclohexanone. This is carbon 1, but in a ring, when that's the only functional group, even when it's not the only functional group, it's going to be number 1. That's 1, 2, 3, 2 carbons ethyl. So this would be 3-ethyl cyclohexanone. Now, I haven't done it, and I always like drawing structures instead of writing words. Well, let's do the following. Why don't you draw the structure for 3-ethyl 2-octanol? Remember, on Wednesday, I'll have a special treat that you have to show up to the video, or not to the video, to the Zoom meeting, because I'm going to cut it out of the video. Clip, click, clip, clip. Ooh, special sound effects. Thank you, Andrew. Thank you, Christiana. All right, how do you decode this to know what to draw? And for all organic molecules, you start from the right, move left. ONA ending, ketone. How many carbons? If that was an E, 8 carbons. Now, I like starting numbering for ketones, aldehydes, and other things from the right. You can go either way. On carbon 2 is my ketone. On carbon 3 is my ethyl group. And I know there are 4 bonds to carbon, so I can put in my hydrogens going at warp drive. meaning real fast. And that's how you get 3-ethyl 2-oxynol. Now, let me remind you, yeah, it's time for that fun game. It's time to play circle and name the functional group, 2 points each. And if you notice on tests 2 and 3, you got to play that game. And there you go. Have fun. Remember, the game is played by circle and name the functional group, 2 points each. Yeah, I think on both I threw in everything but my kitchen sink. Now I don't want to throw that in. It works nicely. Thank you, Christiana. We'll wait for everybody to finish so I can be patient. Thank you, Andrew. Isn't it nice you have an instructor who's patient as opposed to saying, finish, finish, finish. That's not nice. All right, let's look. How do we play this? Look for what's different, what's not carbon, what's not hydrogen to get your attention like that. We have a oxygen here and carbons here and here. And what is this? It's an ether. Ooh, oxygen here and a carbon with a hydrogen. What's this? An alcohol. Ooh, another oxygen. And it's carbonyl, carbon double bond oxygen, hydrogen, and carbons. Let me go to another color so you don't get confused. And if you didn't circle all this, that's okay. And this is an aldehyde. And if we go to B, Ooh, look for what's different. Oxygen and a carbon right here. ROH, you don't have to put that down, but the name is an alcohol. Ooh, another oxygen here. Carbon there, carbonyl. And what is this? It's a ketone. Am I done? No, another oxygen. Carbon here and here. It's an ether. And fine, ooh, one more oxygen, hydrogen, carbon. What is this? It's an aldehyde. If I can spell it. Did I tell you the closer it gets to New Year's, the worse my spelling gets? Well, sometimes. All right. It's bad all the time. I was always the first one down in a spelling bee. All right, now, common names I asked you to learn. When R is R hydrogen, the simplest aldehyde is called formaldehyde. When R and R prime and an ketone are methyl, the simplest ketone is called acetone. Nobody ever calls those by their IUPAC names. And as I mentioned here, acetone is one of the two chemicals used for nail polish remover. In fact, it's made a comeback because of the new high-tech nail polish that's cured under a light, hardened. This takes it off better. Now, once again, carbonyl group, carbon, double bond to oxygen. You should know how to describe with words in a general reaction what a carbonyl group is. Now, we've already gone through this. Primary alcohol, oxidized aldehyde. Secondary alcohol, oxidized ketone. Now, a very special reaction is Friedel-Crafts acylation. And that's where you take a benzene ring and an acid chloride. This is an acid chloride, which I didn't have time to talk about other than this reaction, and you form an aromatic ketone. And you use a catalyst, aluminum trichloride. So here we have a benzene ring, alcohol, acid chloride, aluminum trichloride, and you form this aromatic ketone. And I mentioned some of the uses of aromatic ketones. And this would be a good time And the question is, what would be the two products or starting materials you would use to make that product? Your turn. Remember, don't forget to turn the lab that's due on Wednesday. Thank you, Andrew. And we'll be patient. I was patient. Thank you, Christiana. And what's different? Ooh, a benzene ring. Ooh, carbonyl. And our group, this is an aromatic ketone. We have aluminum trichloride. And how do we make that? React benzene with an acid chloride. And what's the R group? Ethyl. So one of these is benzene. And the other is R is 2 carbons, carbonyl, that carbonyl chlorine. And this is how you do the synthesis. If you look at test number 2, I had this or a similar problem on there. Now, next, we're 4 challenging reactions. The first one, if you take an aldehyde or ketone, and if R prime is hydrogen, it's an aldehyde. If R prime is carbon, it's ketone. Keep your eye on the carbonyl carbon, react with an alcohol and acid catalyst, and you get a hemiacetal or hemiketal. If you use, instead of 1 molecule of alcohol, 2, you get, with an aldehyde or ketone, you keep your eye on the carbonyl carbon. What's attached to it, R prime and R double prime, are still there. And you now get this acetal or ketal. And a special case was when the 2 alcohols are in the same molecule with ethylene oxide. And I talked about protecting groups with her, Dr. Stork, my advisor's advisor. I guess that's my grand advisor. And you don't forget this single bond between the 2 carbons. Students do. And I put that on test number 2. But let's try one. Hold on, I see people writing it down. This is amazing. I got X-ray telescopic vision. I can see for miles and miles. I'm doing a bird song. Anybody ever heard of the group The Birds? You guys are missing out on the good music. How many people know who Jefferson Airplane and Gracie Slick are? Oy vey. It's an oy vey moment. All right, time out for all right, real quick. Back when I was in college, great group was Gracie Slick and the Jefferson Airplane. I saw them play live in Grant Park with about 500,000 other people in Chicago when they had their free concerts. Go to YouTube. I'm going to do that right now. They had a number of great hits. Yeah, teach you people something. And see where it says White Rabbit, Jefferson Airplane? And get the original from here. Only 7.9 million views. Not bad. Listen to it. That's one of my all-time favorite songs by this group. And I saw them do it live. Amazing. Back to chemistry. All right, so if we look at these 2 reactions, let's do one, and I'll do it. And the question is, what's the organic product or products are the following? If we look at this, what's different? Ooh, oxygen and a carbon in a ring. Carbon's here and here. It's a ketone. Now, could have been an aldehyde if R prime was hydrogen. Second thing, carbon hydroxyl group. It's an alcohol. And then we have acid catalyst. Keep your eye on the carbonyl carbon. What's attached to it is still there. You'll have a OH group, O, then R. Now, this whole thing right here is this right here, my R and R prime. They're just connected together. Do you break carbon-carbon single bonds? No, because they're still on that carbon over here. So I'm still going to have my ring. I'm still going to have my methyl group. The carbon right here is going to have a hydroxyl group. Don't forget the oxygen here. And what's my R group? And that would be it. Now, if there were two alcohols instead of OH, the other one would be OCH3, CH2, CH3. Two of them on there. Now, once you have it, if you have an hemiacetal, add acid and water, you get back the aldehyde and the alcohol you would have used to make that. How can you tell this? This is only one of two reactions I know of in organic chemistry where you have two oxygens that are single bonded to the same carbon, this one. And you get back a ketone or aldehyde you would have used to make that, plus the alcohol. The second reaction is when you have an acetal or ketal, again, two oxygens to the same, and that's what you get right there. I think my word is about to tell me reboot, but let's see how long we can go. All right, why don't you try this one? What would be the organic product or products of the following reaction? And on test and the final, I would do this, which would indicate there are two. Once in a while I might forget, but most of the time I don't. Now, while you're working on that, one thing I shall point out that since earlier today, I went through, maybe if we'll have time, I'll go through it a little on Wednesday. But if you were here when I went through the review, test number 4, I considered that my review, but since I'm cutting it out in the video, I may go longer on Wednesday to cover that. Thank you, everybody. All right, look for what's different. A carbon with two oxygens the same, or not same, on that. And on each oxygen, we have carbons. On this, we have a hydrogen, this carbon, or it could have been carbons, and we have carbons. This is an acetal, acid and water. You get back the ketone or aldehyde you would have used to make that acetal, that's that carbon, plus the alcohol. Since I never asked you to balance it, you want to put a 2 there, you can, you don't have to. And therefore, what's our prime? The hydrogen. What's our double prime? The methyl group. What's our? The N-propyl. So what I'll get is this aldehyde. Here's that carbon. And the carbon with the oxygen will be the carbon with the hydroxyl group, in this case, the end one. And that's how you do it. All right, now, next I talked about two of my favorite things. And when you take an alkyl halide and react it with magnesium, you form the Grignard reagent. Remember, it's the magnesium bonded to the carbon with the halogen, and the halogen is bonded to the magnesium. This order is important. It's not it flipped around. And halogens can be chlorine, bromine, or iodine. And why is this important? Because you can take the Grignard reagent and react it with a ketone or aldehyde, second step acid and water, and now you form something special, something very rare, a carbon-carbon single bond. And this is one of the reasons Dr. Victor Grignard won the Nobel Prize, and I want to say somewhere around 1905, 1910 for this reaction. So we better practice it. And here's something for you to have fun with. Am I nice sharing all the fun? Don't answer that. I had to come up with some more jokes. And while you're doing that, I'll be right back. And I'm back. Everybody done? Andrew, are you done too? Thank you. All right, what's different? Oxygen bonded to that carbon. It's got carbons here and here. Could have been a hydrogen, but it's not. If you notice, Dr. White likes ketones and rings. I like them a lot. And it's a ketone. Could have been an aldehyde. Up here, 1, 2, carbon, oh, magnesium bromide. That's a Grignard, where X can be chlorine, or in our case, bromine, or iodine. Second step, acid and water. And what do you get? What's attached to the carbonyl? Carbon double bond to oxygen, our prime or hydrogen, our double prime is still there. This becomes an alcohol, and you do that very special thing. You form a carbon-carbon single bond from the Grignard. What's attached to this carbon right here? The ring. This whole thing is my R prime and R double prime. So you don't break carbon-carbon single bonds, and I don't. And then this carbon right here is that carbon, which is this carbon, and it doesn't matter which side. You have a hydroxyl group, then my R triple prime is N-propyl, the carbon with the magnesium bromide is this carbon bonded to the carbon with the hydroxyl group. And that's how you have fun with a Grignard reagent. And I did. Now, on this reaction, I will never give a synthesis problem. Again, on this reaction, I'll never give a synthesis problem. Now, on Wednesday, I'll continue with chapter or test number 2 material. But this time, I would like to remind you, leaving my class, you should know how to describe with words and a general chemical reaction when you eat a fat or oil, something with fat or oil in it. How do you describe what happens in your stomach after you chew and swallow it? Well, the key functional group is an ester. And in your stomach, there's acid, hydrochloric acid, and water, so it's acid hydrolysis of an ester. And the general reaction, ester, acid, you can put H plus if you don't want to put HCl. And what do you get back? The carboxylic acid plus the alcohol you would have used to make that ester. Eat a fat or oil, key functional group, ester. How do you describe it? Acid hydrolysis of an ester. And here's the general reaction. Ester, acid, and water, get back the carboxylic acid and the alcohol you would have used to make that ester. And if you eat a carbohydrate, a starch, how do you describe with words and a general reaction what happens when you eat a carbohydrate? You chew it and swallow it, goes in your stomach. What's the key functional group that holds glucose together in a carbohydrate? And that's an acetal. And therefore, in your stomach is acid, water, so it's acid hydrolysis, and the key functional group an acetal. And for test number 2, you learn, just like I just went through, if you take an acetal or ketal and react with acid and water, you get back the aldehyde or ketone you would have used to make that, acetal plus the alcohol you would have used to make that. You don't have to put a 2 there, but I do in case anybody is interested. So when you eat a carbohydrate, you should know that how to describe with words and a general reaction. And the key functional group is an acetal that holds glucose together in carbohydrates like starches, and it's acid hydrolysis of an acetal. And here's the general reaction. And the last thing you should know is if you eat something with protein in it. And what's the key functional group in protein? An amide. So when you eat it in your stomach, when you chew and swallow it, you have hydrochloric acid. So it's acid hydrolysis of an amide. Again, the key functional group in a protein is an amide. And for test 3, you learned how to describe the general reaction, acid, and here we'll show the HCl and water. Take an amide. I won't write it down, but our prime and our double prime one or both can be hydrogens, but you know that. And you get back the carboxylic acid you would have used to make that amide, plus not the amine, but the amine salt. You would have used to make that amide. So acid hydrolysis of an amide is the general how you describe when you eat a protein. And the general reaction is this, any amide reacting with acid and water, you get back the carboxylic acid you would have used to make that amide plus the amine salt. And with that, I'm done for today. Don't forget, use your hourly exams as practice problems. A week from today, I will be giving the final exam. We'll have no Zoom meeting. So about 1 o'clock, probably earlier than that, I'll send out a password for the test for a final exam PDF file, and you'll have until 1 p.m. Tuesday to finish and upload your final exam. With that, I'll say, gang gesund. Remember, that's Yiddish for going to hell. If you haven't had your flu shot, make sure you got one. I got mine a month ago almost. And I also got my 3rd booster because unfortunately winter's coming and a flu, and I wonder if COVID is starting to pick up in California. Hope it doesn't here. But anyways, gang gesund. Goodbye. I stole that from Beverly Hillbillies. Bye, Andrew.